That was really peppy. Good afternoon, everyone. My name's Gareth Jones. I'm Managing Director of Fairheat. I'm Chair of the ADE Heat Network Forum and, importantly, Chair of the BESA HIU Test Standard Steering Group and Technical Committee. For just under the next 30 minutes, we're going to be talking about heat networks. As everyone's aware, COP26 in full flow, and the spotlight's being shone onto carbon emissions in different sectors of the economy. Pretty much top of that list is the question of how do we decarbonise heat, and particularly heat in buildings, which is the tricky bit. The provision of heating hot water in buildings accounts for about a quarter of UK's total emissions. So we're going to need to find a way to eliminate those emissions if we're going to meet our long-term targets. As part of its review, the Climate Change Committee's identified heat networks as one of the key vehicles for reduction in carbon emissions from heat. Very briefly, heat networks are a technology agnostic approach where you have a centralized heat source and then you distribute via pipework to a bunch of end users. The scale of these can be anything from communal heating systems within single buildings through to citywide heat networks. Off the back of the CCC's recommendations, the Department for Business, Energy and Industrial Strategy, BEIS, has set an ambition for 19% of heat to be supplied from heat networks by 2050. That's up from about 2% today, so it represents massive growth. And that brings us on to the topic for today. How do we ensure that heat networks achieve their potential in the UK? In particular, what do we need to do from the perspective of those who are delivering heat networks on the ground? So that's the introduction. Today I've got an absolutely superb panel in the form of Phil Jones, Chris Parsloe, Charlotte Large and Jan Hansen. Going through quickly, Phil has spent the last 40 years trying to make buildings more energy efficient, and in addition to having a fantastic last name, he's a tireless ambassador for the industry. He's an independent energy consultant, fellow of CIBSE, lead author of CIBSE CP1 Heat Networks Code of Practice. Phil is a visiting professor at London South Bank University, specialising in large heat pumps, heat networks, and in particular, ultra-low temperature fifth generation heat networks. Welcome, Phil. Chris Parsloe is one of the leading experts in the industry and has written several publications on closed pipe system design dating back to the mid-1990s. He's the main author for the new CIBSE Heat Networks Design Guide, which was great to see finally got published last month. Congratulations on that. We're then on to Charlotte Large. Charlotte's worked on low carbon building solutions and district heating for almost 20 years. Over this time, she worked as a consultant in AECOM's Sustainable Development Team. She's worked in local government delivering heat networks, including Islington's award-winning Bunhill Heat Network, and she's worked for central government departments in various low-carbon heat advisory, delivery and strategy roles. She currently works for Equans in a strategy, policy and innovation role, including developing decarbonisation strategies for their 7 growing city heat networks. Charlotte is also currently chair of HeatNet Jobs and Skills Working Group, which is looking to drive the Industry Council to deliver focused action on skills, training and diversity and inclusion. Welcome, Charlotte. And finally, Jan Hansen, not least, Managing Director at SAV, and over the past 15 years or so has had a deep involvement with both the technical and commercial side of the UK heat network industry. Given his Danish roots, Jan has a unique insight into the evolution and decarbonisation of heat networks in the UK and the way forward, benefiting from close cooperation with big Danish heat network players such as Kamstrup and Danfoss. Welcome, Jan. So, Chris, Phil, Charlotte and Jan, good afternoon. Thanks for agreeing to come on today. So my role in this discussion is to get conversation going and basically to ask you some difficult questions. We've not got so long today, so what I really want to do is focus in and move around the group a bit. I've already framed the issue at the start, so what I really want to do is talk about heat networks, massive potential. We know that there is a big potential there. What are we going to do to actually deliver on that in the UK? What I'd really like to do today is focus more on a technical delivery perspective and really look at this from the perspective of those contractors who are delivering heating systems on the ground. So first question, in general, electrification of heat, particularly heat pumps, has been identified as the way forward for heat decarbonisation in the UK. We know that this is going to be the same for heat networks. So what are the key changes that we're going to see to heat network design and operation as a result of shifting to heat pumps? And what does this mean in practice for heat networks for those who are installing them? Chris, can I start with you?
Yeah, I mean, I'm always focusing on the technical aspects of how you make a pipework system function with all of these competing objectives. Obviously, with regard to heat pumps, I think temperature does become one of the critical things, and I think a lot of UK designers have not been used to thinking about how you get good control of flow and return temperatures in a way that maximizes the output from these from heat sources such as heat pumps. So clearly, reduction in operating temperatures is critical. Getting down to 60 degrees flow, possibly as low as possible return temperature. To achieve that, you need very much better focus on bypasses around the system, so that there's no shortcuts for the water back to the main plant. But also things like simple things like valve selections. Simple TRVs don't give you very good authority over control of flow rate, and that can affect the return temperature as well. So all of these things become far more critical if you're going to focus on integrating some of these heat sources that maybe operate at temperatures that we're not particularly used to.
Charlotte?
Can I just add the point around, obviously a lot of changes in terms of thinking about the design in terms of flow and return and temperatures, but I think it's also not only from a design perspective, also making sure that they're commissioned well and that they do then operate as they were designed to, because I think that's going to be really critical because, like Chris said, we need those temperatures to make sure that we've got really efficient running systems, and also in the O&M as well. So making sure that we continue to ongoing having those the return temperatures that allow the efficiency of the heat pumps, but also then the knock-on savings in terms of cost for operation for the users.
It's an interesting point coming back. Actually, yeah. So Jan, come on to you.
Yeah, no, I've just been sort of part of the journey where we're starting at 80 degrees, that was the norm, or 82 degrees, and then 70 was the norm, and then we were struggling to push it further with air source heat pumps. Yes, 55, but basically what we are seeing is that the whole let's say supply chain needs to be adopting this. So one of the big issues that we are seeing is that when we see radiator schedules is that people actually don't fully appreciate how to size radiators if you're running at lower temperatures. So the whole selection and the whole supply chain really needs re-educating. And then fully concur with both Chris and Charlotte that then the commissioning and setting up and selection of valve means something. But what we are seeing is that sort of the lack of understanding in some of the equipment, and then trying to convince developers to sort of say, yeah, but you can't do as you used to. So a radiator will have to get a little bit bigger, or your pipes spacing on underfloor heating might have to be tighter, etc. But that is crucial in all of this if you want that low return temperature for that new type of energy source being heat pumps.
I mean, that's something we see a lot as well, and I think a few of you made the point now, and particularly Charlotte and Jan, around actually deliverability. It's all very well doing design, but you actually have to make sure that comes through in practice. I mean, Phil, from your perspective, from the CP1 perspective, what can we do to improve deliverability of things on the ground?
I think commissioning is key. I think we need a quality assurance scheme to actually get greater performance out of these schemes. And I think that CP1 and the minimum requirements in it actually do give us a foundation towards that. So I think we are going to see quite a lot of change in the heat network market. I just had two sort of practical things on top of what's been said, and that is, I think we're going to see very large heat pumps on heat networks, but very large thermal storage associated with those, and we are going to need to change the way we control and commission those. But we're also going to see a lot more polymer pipe, pre-insulated, because we are going to be operating heat networks at much lower temperature. So it might not be steel anymore.
Thanks for that. I just want to change tack slightly, and I want to pick up on something Jan was talking about earlier. Because Jan, you were talking a lot about developers and changing approach, but I think what we've seen, and this is really a mindset where we've been, is a lot of the heat networks to date in the UK have been installed as part of new build developments, and that's really where a lot of the heat network installations been. But if we're going to hit that 19% target, that's going to have to change, and what we're going to see over time is much more of a shift towards retrofitting existing buildings. In that context, from the perspective of those who are delivering these systems, it would be really interesting to just have a chat through what should we be doing now to make sure that heat networks can successfully connect to existing buildings, and more specifically, are there changes we should be looking to actively make with existing building systems to then actually allow us to accommodate low carbon heat sources and connect in heat networks. Charlotte, it'd be good to get your thoughts on that from your perspectives.
Yeah, I mean, I think this is a really important point, not just for heat networks, but also for all low carbon heating, especially with the current shift as kind of the focus on electrification of heating. So, regardless of that heat network having a higher proportion of heat pump on it at large scale, that building could also, like we said, have a building scale solution. So this is kind of across the board something that actually buildings should be thinking about. And that is to think about, the heat losses of the building and the rooms, and also the emitters, and whether they are able to be set up or whether there needs to be changes to the system to enable low carbon heat, so electrification heat pumps coming in. And I think this is really important, because what we don't want to do is get to a situation where, if there is a boiler or a current system coming to the end of its life, that there isn't the kind of preparation works in place to avoid that kind of distressed situation, where not only are you trying to put in the new heat pump system or connect to a heat network, but you're also trying to maybe potentially look at the fabric, but also look at the wet heating system and how that operates. And I think someone's mentioned it already. I think it's not just around how the wet heating system operates, but it's also the controls of that as well, because that's going to be really critical in terms of the ability to design systems, or to have systems that can easily connect into low carbon solutions, whether that's building scale heat pumps or heat networks.
Phil, do you have any views on that?
Yeah, I think there's an awful lot we can do to retrofit buildings. I think there are big heat pumps around that will operate at 80, but the lower the temperature we can operate, the higher the COP of the heat pumps. And there's a lot you can do. You don't need to turn to fabric first all the time. There's a lot we can do to tune the systems in buildings. Very often, it's quite common to get buildings down to 70-50 because the radiators have originally been oversized, but that needs tuning of pumps, possibly a new central pump, but also insulating the secondaries and preventing hot corridors, all of which is in the code of practice. And I would just add, the other thing that's in the code of practice is acceptance testing, making sure that when you've put it in and you've commissioned it, you really feel that the delivery is there of temperatures and hot water temperatures.
Chris, you indicated you had something to come in on that.
Yeah, I mean, I think with existing buildings, they are a challenge. I mean, I still see buildings that have got 4-port and 3-port valves in them, which all are quite difficult to adapt to an approach where you're going to try and gain control over a turn temperature. And also things like pressure relief valves are quite common, because they all these things were all quite traditional things that were done through the 80s and 90s and into the noughties. So we still find those things, and because I've been involved in some of the design guidance that's led to variable speed pumping systems, starting from the late 90s and then with guidance over the last 10, 15 years. I know some of that guidance, some of which is, in publications I've produced, doesn't fit with, this same thinking. So some of that is really a little bit now redundant and obsolete. I think that the long and short of it is that if you want existing buildings to fit into a heat network, they need to be designed to the same principles as the heat network. So everything that's coming out in CP1 and also in the Heat Networks Design Guide, those principles of how you design a system, they should really be going back into anybody who's dealing with an ordinary radiator system, fan coil system, chilled water system, whatever, for a building which potentially might one day be connected to a heat network. We need to, the guidance seems to me a little bit, anybody who's working on, say, a fan coil system may not think this sort of conversation is relevant to them. And that's a slight worry, I think.
Thanks for that. I think a lot of what you're also talking about is also applicable to any building that's can connect to any low carbon heat source. And I think one of the things that coming back to Phil's point earlier, that there is one advantage that heat networks give, that you can actually run them at slightly higher temperatures with centralized big large heat pumps and storage, which does allow you to run at higher temperatures to then allow the decarbonisation. Charlotte, you want to come in on this?
Yeah, I was just going to add that, in talking to those building users, that it's worth also sort of drawing out that in some cases, or in many cases, kind of doing this work now would also help with their existing system. So if it was done as preparation work, if they've got, say, condensing boiler, the boiler is more likely then to condense, so could save energy and costs from the outset, but also then puts them in a position to be ready for low carbon heating as and when it comes on.
Thanks. I just want to actually, Jan, I'm going to come on to you now because I think we need to move on from this. I think one of the things that you mentioned actually earlier is actually that we need to get skills up within the industry. And I think it's great. We've now got CP1, we've got this design guide. I think there's a lot of thinking gone in terms of making improvements on from a design perspective, though I think we still do need quality assurance there. But if we're coming back, how do we ensure that we do develop the skills we need in the industry and get the learning embedded? At the same time, it's got really high growth in the industry. How do we square those two things together?
If I can, on sort of what I've seen, being doing sort of the heat network journey and helping installers on that journey, what I can see a lot will come from simpler products that can perform the things. So you can start doing commissioning by numbers, so that we don't need a completely specialist labor force to do it, because if everything has to be specialist install, then obviously the uptake will be difficult. So therefore, as manufacturers, we are seeing a lot coming out which are relatively simple, can be done by numbers, and people can actually apply it easier. And then, verification later is then also easier. So I can see a lot in product development helping this process, to upskill and make sure we can get to here. But the understanding of heat networks and return temperatures and differential pressure, unfortunately, we got to do with water that is flowing, and we got to do with pressure, and they are two difficult areas. So therefore, getting that into sort of layman terms and making sure everybody appreciates it, we need some very core key benchmarks, and there, we have always, as an organization, look at that return temperature, and if it's high, you've got a temperature, and then I'm sorry, you need to go to the doctor, and the doctor is looking at the system. But relatively simple things that people can work with to ensure that it works later. Yeah.
Charlotte, you're chairing the HeatNet Jobs and Skills Working Group. What approach are you seeing coming through there? What's the thinking?
Yeah, so we are very conscious that there will increasingly be a bit of a skills gap in this space, especially as all low carbon heating technologies grow. So we're having conversations around what we can do with apprenticeships. I think there's a lot of good work that's being done already by a lot of organisations, but encouraging that and doing more of that kind of ground up. Building that expertise and having more apprenticeships and grads coming on to schemes is really important. and also standardising those apprenticeships. So at the moment, there are a couple of registered apprenticeship schemes for the industry around design and installation, but they've been very much done by a single organisation. And what we see is there's quite a lot of training done by manufacturers and organisations, and but that's not kind of shared across the industry, or it's not standardised. So there is currently work being done by the industry to introduce an apprenticeship scheme for O&M on heat networks as well, which would have specialism. So there's quite a lot of work being done in that area, and I think that's really important because we do need to build up the skill set and the expertise from the ground, because it is quite specialist. But also we think that there's a real opportunity in terms of retraining and bringing skills from elsewhere. So we're also talking about what we can do in that space too.
Great, thanks for that. We've got a ridiculously short topic for something we could probably spend time slot for something we spend the whole day talking about. What I'd like, if I could, just last 8 minutes, is have a couple of minutes from each of you, just having, if you could go through what's the single most important thing that we could do, that those actually delivering heat networks need to be thinking about and get right in order for us to allow heat networks to deliver their full potential. Phil, can I start with you?
So I think just to give a bit of context, the heat networks are going to grow massively, partially because of a lot of government support, money, but also we are moving into an era of greater regulation around heat networks to turn them into utilities. We do need more people, more training courses. We're trying to set some up at London South Bank University. But I think above all, quality assurance is absolutely key. Making sure that these systems actually perform in use. And I think that training is absolutely at the core of that.
Yeah. Thanks for that. Charlotte, what's your view?
Yeah, so I think there's a lot that we can do in preparing buildings. So I think now, when people are going in, whether it's new build or whether it's existing buildings, like everyone said already, thinking a lot in detail about those designs of those wet systems or other systems, and how can they be designed, how can they be tweaked, how can they be adjusted to take low carbon heating, because I think we'll see as we move into the late 20s and 30s, there'll be more of a need to, when a system falls over, to be either replaced by a low carbon heat pump or connect into a heat network if and when zoning comes into regulation.
Yeah, thanks for that. Chris, what are your thoughts?
If I had to say what's the most important thing, I would say training, really. Training and getting the right level of specialist knowledge to the people designing these systems. I think anybody who is approaching one of these systems whilst also thinking about the ductwork design, the smoke ventilation, all of the other things that a building services engineer gets called upon to consider, is the wrong approach. You need somebody who really is just, there's so much in this topic that you need people to really specialize on it. And I would say just getting that understanding of pressures around a system and flow rates and what's going to happen to them under different operating conditions, understanding all of the hardware, the valves and components that go into the systems, really understanding exactly how they work, so that you can know how to select them and when to where to put them, and how to deal with them when they don't work. Things like water quality issues, which are a huge topic for closed water systems in the UK. How do you address that? Most design engineers haven't got any idea whatsoever, and just not part of the training that they've had. Commissioning issues we've touched on as well. So training, I think, is the trouble. All the problematic systems I've looked at are, somewhere along the line there was a gap of knowledge there, which somebody didn't, inadvertently has caused a problem without really. It's because they didn't really have enough background knowledge. It really is quite an in-depth area that you've got to really be immersed in, I think. Computer software, I would say, is the other thing. If we can get some computer software that would assist with a lot of these things, which I think is feasible, and I have some ideas about that. That's also might help things.
Yeah, and what's your view? One thing we could do.
Obviously can only concur with a lot of the things that are being said. The quality assurance later on, but this commissioning verification, the simplicity of it, and I think when we are moving towards low carbon heat sources, the room for error is basically narrowing in the same, let's say, trajectory as the temperature going down. So, if you had 80 degrees, well, it wasn't well commissioned, didn't matter too much, it will increase prices slightly. But with electrification and non-commissioned or well-commissioned systems, and then heat pumps in there, basically the only thing that will go up is the cost of heat. And we've already seen what that means today when, you've seen the gas price. So therefore, commissioning, I know a lot of people are saying it, but it's actually making commissioning a relevant issue for people doing it on site. So it is not just specialist, because we already got lots of installers, and therefore if you can come up with products that makes it easier for them, that would be great. And we keep saying it has to be low cost. So therefore, the infrastructure to monitor and verify and then continuously monitor, if you can do that in the existing, let's say, infrastructure you need regardless for paying bills and the rest of it, then again, that's where you can make a simple red light system. Red, it's bad. Orange, you need to look at it. Green, everything is okay. So more people can engage with it, because if we are going to rely on specialists only, then we will have a challenge because we won't have them. We need to sort of come from a place where, we can get to specialists, but, a lot more people can actually see what's going on. And that's obviously always the game is to come out and develop products like that. And that's where then it comes into simple dashboards, simple sort of understandable through computer systems based on data available from the networks. But commissioning is where we have seen the biggest success, and simple products that help that commissioning process is where we've seen the most successes. So, I can only, concur on that.
It's yeah, I think when we're looking across at a whole, what's coming back and what we're hearing here is training is incredibly important. And I think it's training, quality assurance. How do we actually make sure that we verify what's gone on and make sure we get things right? It's an interesting point you just made, Jan, I think as well. One of the things about having cheap, low cost subsidized gas for a long time is it's allowed us in building services to be very, very permissive with the approach we're taking. I think now we're going to have to get a lot more structured around delivering and making sure that we really make sure the systems we put in place really work, and we do everything we can to achieve that. So I think we're actually coming up to a wrap up on that. Is there anything, last thing anyone wants to add?
I just wanted to add, Gareth, that I think it has to be recognised throughout the contracting world that heat networks its time has come. And that's recognised only yesterday by the government actually putting more money into what is called the Green Heat Network Fund. It's now gone up from 270 million to 330 million between now and 2025. So this market is set to grow and grow.
Brilliant. Well, that's good. Good point to end on. That's everything from us. Thank you, everyone. Thanks for attending today, and thanks to all my panelists.
Thank you.
Thanks all.
Thank you.